Hello and welcome. Today, I will be whispering to you about one of the most exciting and transformative periods in modern history, the space race. This period of intense competition between the United States and the Soviet Union not only pushed the boundaries of human potential but also laid the groundwork for many of the technological advancements we enjoy today. The space race began in the late 1950s, fueled by the Cold War rivalry between the United States and the Soviet Union. Both superpowers saw space exploration as a way to demonstrate their technological and ideological superiority. The competition officially kicked off on October 4, 1957, when the Soviet Union launched Sputnik 1, the world's first artificial satellite. This historic event sent shockwaves across the globe and marked the beginning of humanity's journey into space. The launch of Sputnik 1 was a significant achievement for the Soviet Union. The satellite, which was about the size of a beach ball, orbited the Earth and transmitted radio pulses that could be detected by radio operators worldwide. This accomplishment showcased the Soviet Union's advanced rocket technology and their ability to reach beyond the Earth's atmosphere. The success of Sputnik 1 not only boosted Soviet pride, but also intensified the sense of urgency within the United States to catch up and surpass their rival in space exploration. In response to the Soviet Union's early victories in space, the United States accelerated its own space program. In 1958, President Dwight D. Eisenhower established the National Aeronautics and Space Administration, NASA, to coordinate and lead the nation's space efforts. One of NASA's first major projects was the Mercury program, which aimed to send an American astronaut into space. The program faced numerous challenges and setbacks, but it ultimately succeeded in May 1961 when astronaut Alan Shepard became the first American in space aboard the Freedom 7 spacecraft. While the United States celebrated Shepard's achievement, the Soviet Union continued to make groundbreaking strides. On April 12, 1961, Yuri Gagarin, a Soviet cosmonaut, became the first human to journey into outer space and orbit the Earth. His mission aboard the Vostok 1 spacecraft was a triumph for the Soviet space program and solidified Gagarin's status as an international hero. Gagarin's successful mission demonstrated the Soviet Union's ability to send humans into space and safely return them to Earth, further fueling the space race rivalry. As the competition intensified, both nations set their sights on even more ambitious goals. For the United States, the ultimate objective was to land a man on the moon. In 1961, President John F. Kennedy delivered a historic speech before a joint session of Congress, declaring that America would land a man on the moon and return him safely to Earth before the end of the decade. This bold vision galvanized the nation and led to the launch of the Apollo program, a series of missions designed to achieve this monumental goal. The Apollo program represented a monumental effort involving thousands of scientists, engineers, and astronauts. Each mission built on the successes and lessons of its predecessors, culminating in the historic Apollo 11 mission. On July 20th, 1969, astronauts Neil Armstrong and Edwin Buzz Aldrin became the first humans to set foot on the lunar surface. Armstrong's famous words, "That's one small step for man, one giant leap for mankind," echoed around the world, symbolizing the triumph of human ingenuity and determination. The moon landing was not just a victory for the United States, it was a significant milestone for all of humanity. It demonstrated that with dedication, collaboration, and innovation, seemingly impossible goals could be achieved. The success of the Apollo 11 mission captivated the imagination of people worldwide and inspired a generation of scientists, engineers, and dreamers. Beyond the remarkable achievements of sending humans to the moon, the space race had far-reaching impacts on technology and society. The intense focus on space exploration led to rapid advancements in various fields, including rocketry, telecommunications, and materials science. Technologies developed for space missions found applications in everyday life, from satellite communications to medical imaging and even the development of lightweight materials used in sports equipment. The space race also fostered international cooperation in space exploration. Despite the competition between the United States and the Soviet Union, both nations recognized the potential benefits of collaborating on scientific research and exploration. In the years following the Apollo missions, the United States and the Soviet Union, later Russia, began to work together on joint space missions, paving the way for future international partnerships such as the International Space Station, ISS. The legacy of the space race continues to influence space exploration today. The spirit of competition and the drive to push the boundaries of human knowledge have persisted, leading to new and exciting missions to explore our solar system and beyond. Space agencies around the world, including NASA, the European Space Agency, ESA, and new players like SpaceX, continue to build on the foundation laid during the space race, striving to answer fundamental questions about our universe and our place within it. In conclusion, the space race was a period of intense rivalry and remarkable achievement that transformed human understanding of space and our capabilities to explore it. The achievements of this era, from launching the first artificial satellite to landing humans on the moon, continue to inspire and drive progress in space exploration. As we look to the future, the legacy of the space race reminds us of what is possible when nations and individuals come together with a shared vision of exploration and discovery. The successful Apollo 11 mission was a turning point, but it was far from the end of the space race. Following the moon landing, the United States continued to push forward with additional Apollo missions, each contributing to our understanding of lunar science and technology. Apollo 12, launched in November 1969, landed on the moon's ocean of storms, allowing astronauts Charles Conrad and Alan Bean to collect more lunar samples and conduct scientific experiments. These missions not only demonstrated the robustness of NASA's capabilities, but also showcased the benefits of international collaboration as other countries began to contribute scientific instruments and experiments to be carried aboard the lunar missions. The Apollo missions continued until Apollo 17 in December 1972, marking the end of an era in manned lunar exploration. The final mission was notable for being the first to include a geologist, Harrison Schmitt, among the crew. Schmidt's expertise allowed for more detailed scientific observations and sample collections, significantly enriching our understanding of the moon's geological history. The Apollo program, with its series of missions, left an indelible mark on space exploration, setting the stage for future endeavors and inspiring generations of scientists and engineers. As the Apollo program wound down, the focus of the space race began to shift. The United States and the Soviet Union started to explore new frontiers, including space stations and robotic missions to other planets. The Soviet Union had already achieved a significant milestone with the launch of Salyut 1 in 1971, the world's first space station. This achievement underscored the potential for humans to live and work in space for extended periods, paving the way for future space habitats and the continuous human presence in space. In the United States, NASA initiated the Skylab program, which became America's first space station. Launched in 1973, Skylab hosted 3 crewed missions during which astronauts conducted scientific experiments, observed the Earth, and tested the effects of long-duration spaceflight on the human body. These missions provided invaluable data and experience that would later inform the design and operation of more advanced space stations, including the International Space Station, ISS. Meanwhile, both superpowers continued to push the boundaries of robotic space exploration. The Soviet Union's Lunar program, which included the successful Luna 16 mission that returned soil samples from the Moon in 1970, demonstrated the potential for automated sample return missions. This was followed by the ambitious Mars 3 mission, which became the first spacecraft to land on Mars, although contact was lost shortly after landing. These missions highlighted the Soviet Union's commitment to exploring the solar system and advancing space technology. In the United States, the Voyager program was launched in 1977, marking a significant leap forward in robotic space exploration. Voyager 1 and Voyager 2 were designed to take advantage of a rare planetary alignment, allowing them to conduct a grand tour of the outer planets. These spacecraft provided humanity with the first detailed images and data from Jupiter, Saturn, Uranus, and Neptune, vastly expanding our knowledge of the solar system. The Voyager's discoveries, from the volcanic activity on Jupiter's moon Io to the intricate ring system of Saturn, captivated the public and underscored the importance of space exploration. As the 1980s approached, the space race evolved from a competition into an era of cooperation and shared scientific goals. The United States and the Soviet Union, along with other nations, began to recognize the benefits of working together in space. This spirit of cooperation was exemplified by the Apollo Soyuz test project in 1975, where an American Apollo spacecraft docked with a Soviet Soyuz spacecraft in orbit. This historic mission symbolized a thaw in Cold War tensions and demonstrated the potential for peaceful collaboration in space exploration. The culmination of these efforts was the development of the International Space Station, ISS, a multinational project involving NASA, Roscosmos, ESA, JAXA, and CSA. Launched in 1998, the ISS became a symbol of international cooperation, serving as a laboratory for scientific research, a platform for technological innovation, and a testament to what humanity can achieve when working together. The ISS continues to operate today, fostering advancements in medicine, materials science, and our understanding of the effects of long-duration spaceflight on the human body. The legacy of the space race extends beyond the technological and scientific achievements. It inspired a generation of dreamers, scientists, and engineers who continue to push the boundaries of what is possible. The advancements made during this period laid the foundation for today's space exploration efforts, from the continued exploration of Mars to the plans for returning humans to the Moon and eventually sending crewed missions to Mars. The space race also had a profound impact on education and public interest in science and technology. The excitement and wonder generated by the milestones of space exploration inspired countless individuals to pursue careers in STEM fields, driving innovation and progress across multiple disciplines. Educational programs and initiatives, such as NASA's outreach efforts and the establishment of space camps, aim to nurture the next generation of explorers and innovators. As we look to the future, the spirit of the space race lives on in the ambitious goals of space agencies and private companies alike. The Artemis program, led by NASA, aims to return humans to the Moon by the mid-2020s, this time with a focus on sustainability and the establishment of a lunar base. This endeavor seeks to build on the legacy of Apollo, leveraging modern technology and international partnerships to achieve new milestones in space exploration. Private companies, such as SpaceX and Blue Origin, have also entered the space arena, bringing new energy and innovation to the field. These companies are not only developing the technology to make space travel more accessible, but are also setting their sights on Mars and beyond. The dream of sending humans to other planets, once a distant aspiration, is now a tangible goal within reach, thanks to the foundation laid during the space race. In summary, the space race was a transformative period that pushed the boundaries of human potential and reshaped our understanding of the universe. The achievements of this era, from the first artificial satellite to the moon landing, continue to inspire and drive progress in space exploration. As we look to the stars, we are reminded of the power of innovation, collaboration, and the enduring human spirit that drives us to explore the unknown. As the space race progressed into the late 1970s and 1980s, it became clear that the competition had fundamentally altered the trajectory of human civilization. The United States and the Soviet Union had pushed each other to unprecedented heights, achieving feats that once seemed the realm of science fiction. However, the real legacy of the space race lay not just in the immediate achievements, but in the broader impact on technology, culture, and international relations. One of the most significant outcomes of the space race was the development and deployment of satellite technology. Satellites revolutionized communication, navigation, weather forecasting, and scientific research. The launch of the first communication satellite, Telstar, in 1962, enabled live television broadcasts across the Atlantic and laid the groundwork for the global communications network we rely on today. Weather satellites, such as the Tyros series, provided invaluable data for meteorologists, improving our ability to predict and respond to natural disasters. Navigation systems also benefited immensely from space technology. The development of the Global Positioning System, GPS, was a direct outgrowth of space-based navigation research. Initially developed by the U.S. Department of Defense, GPS has since become an integral part of daily life, enabling everything from precise mapping and navigation to time synchronization for financial transactions. This technology, which emerged from the space race, has had a profound impact on global commerce, transportation, and even social interactions. The cultural impact of the space race cannot be overstated. The images of Earth from space, such as the iconic Earthrise photograph taken during the Apollo 8 mission, fundamentally changed how humanity viewed itself. For the first time, people saw the Earth as a fragile, interconnected whole, floating in the vastness of space. This new perspective fueled the environmental movement, emphasizing the need to protect our planet and its ecosystems. The blue marble photograph, taken during the Apollo 17 mission, became a powerful symbol of environmental awareness and global unity. The space race also inspired a wealth of literature, film, and art, capturing the imagination of millions. Science fiction authors like Arthur C. Clarke and Isaac Asimov wrote compelling stories about space exploration, imagining futures where humanity ventured beyond the confines of Earth. Films like 2001: A Space Odyssey, directed by Stanley Kubrick, brought these visions to the big screen, blending scientific accuracy with artistic expression. These cultural artifacts not only entertained but also inspired future generations to dream of and work towards exploring the cosmos. Education and public outreach became key components of the space programs, as both the United States and the Soviet Union sought to cultivate a new generation of scientists, engineers, and explorers. NASA's investment in educational programs, such as the establishment of space camps and partnerships with schools, aim to ignite a passion for STEM, science, technology, engineering, and mathematics subjects. These efforts paid off, as many young people who grew up during the space race went on to pursue careers in these fields, driving technological innovation and scientific discovery in subsequent decades. International cooperation in space exploration began to take root during this period, laying the groundwork for future collaborative efforts. The Apollo Soyuz test project in 1975 was a landmark event, symbolizing a thaw in Cold War tensions and demonstrating the potential for peaceful collaboration in space. This mission saw an American Apollo spacecraft dock with a Soviet Soyuz spacecraft, allowing astronauts and cosmonauts to conduct joint experiments and share their cultures. The success of this mission fostered a spirit of camaraderie and mutual respect that would pave the way for future partnerships. The establishment of the International Space Station, ISS, in the late 1990s marked a new era of multinational collaboration in space. The ISS, a joint project involving NASA, Roscosmos, ESA, JAXA, and CSA, became a hub for scientific research and technological development. Astronauts from various countries live and work together on the ISS, conducting experiments that advance our understanding of space and its effects on the human body. The ISS serves as a testament to what humanity can achieve when nations set aside their differences and work towards a common goal. The legacy of the space race is also evident in the rise of private space companies. Entrepreneurs like Elon Musk, Jeff Bezos, and Richard Branson have taken the lessons of the space race and applied them to their ventures, aiming to make space travel more accessible and sustainable. Companies like SpaceX, Blue Origin, and Virgin Galactic are developing new technologies that promise to reduce the cost of launching payloads into space and open up new possibilities for exploration and commercialization. SpaceX, in particular, has made significant strides in recent years. The development of the Falcon 9 rocket, which features a reusable first stage, has dramatically lowered the cost of access to space. SpaceX's ambitious Starship program aims to develop a fully reusable spacecraft capable of carrying humans to Mars and beyond. These advancements build on the foundation laid during the space race, demonstrating the enduring impact of that era's technological breakthroughs. As we look to the future, the spirit of the space race continues to drive innovation and exploration. NASA's Artemis program aims to return humans to the moon by the mid-2020s, this time with the goal of establishing a sustainable presence. The lessons learned from the Apollo missions, combined with modern technology, will enable a new era of lunar exploration, potentially paving the way for future missions to Mars. The European Space Agency, ESA, the Russian Space Agency Roscosmos, and other international partners are also contributing to these efforts, highlighting the importance of collaboration in achieving ambitious space exploration goals. New missions to Mars, such as NASA's Perseverance rover and ESA's ExoMars program, seek to uncover the mysteries of the red planet, including the search for signs of past or present life. The advent of commercial spaceflight is poised to revolutionize the industry, making space more accessible to a broader range of people and organizations. Space tourism, once a distant dream, is becoming a reality, with companies like Blue Origin and Virgin Galactic offering suborbital flights to paying customers. These developments promise to democratize space exploration, allowing more people to experience the wonders of space firsthand. As we delve deeper into the legacy of the space race, it becomes evident that the ripple effects of this monumental period extended far beyond the immediate technological achievements and scientific discoveries. The space race not only shaped the geopolitical landscape of the mid-20th century, but also fundamentally transformed how we view our planet and our place in the cosmos. The immediate post-space race era saw the United States and the Soviet Union, later Russia, leveraging their space technology for a variety of applications, both civilian and military. The development of satellite reconnaissance capabilities provided unprecedented intelligence-gathering tools, significantly impacting global security dynamics. The use of satellites for communications, navigation, and weather forecasting became integral to modern infrastructure, facilitating the growth of global economies and enhancing international connectivity. One of the most profound impacts of the space race was the way it spurred global cooperation in scientific research. While the competition between the United States and the Soviet Union was intense, the achievements of both nations fostered a sense of shared human accomplishment. This sentiment paved the way for collaborative efforts in space exploration, exemplified by the Apollo Soyuz test project and later the construction and operation of the International Space Station, ISS. The ISS, orbiting Earth since 1998, stands as a testament to what can be achieved when nations work together towards a common goal, conducting vital scientific research that benefits all of humanity. The technological advancements driven by the space race also had far-reaching implications for everyday life. Innovations in materials science, such as the development of lightweight and heat-resistant materials, found applications across various industries, from aerospace to consumer electronics. The miniaturization of electronic components, essential for space missions, led to the development of compact and powerful devices that have become ubiquitous in our daily lives, including smartphones, laptops, and medical equipment. Furthermore, the environmental perspective gained from space exploration profoundly influenced global awareness and policy. The iconic images of Earth taken from space, such as the blue marble and Earthrise, highlighted the fragility and interconnectedness of our planet. These images became powerful symbols for the environmental movement, inspiring efforts to address issues like climate change, pollution, and biodiversity loss. The perspective of seeing Earth as a singular, fragile entity in the vast expanse of space underscored the importance of stewardship and sustainability. Education and inspiration were perhaps among the most lasting legacies of the space race. The dramatic milestones of space exploration captured the imaginations of millions, inspiring generations of students to pursue careers in science, technology, engineering, and mathematics, STEM. Educational initiatives launched by NASA and other space agencies aimed to nurture this interest, leading to a surge in technological and scientific innovation. The space race demonstrated the power of ambitious goals and the importance of investing in education to achieve them. As humanity looks to the future of space exploration, the lessons learned from the space race continue to guide and inspire. The Artemis program, spearheaded by NASA, aims to return humans to the moon by the mid-2020s, with the goal of establishing a sustainable human presence. This program seeks to build on the legacy of Apollo, incorporating modern technology and international partnerships to achieve new milestones in lunar exploration. The experience gained from these missions will be crucial for future endeavors, such as the ambitious goal of sending humans to Mars. International collaboration remains a cornerstone of contemporary space exploration. Space agencies around the world, including NASA, Roscosmos, ESA, JAXA, and CNSA, China National Space Administration, are working together on a variety of projects, from planetary exploration to space station operations. The success of these collaborations highlights the importance of pooling resources, knowledge, and expertise to tackle the complex challenges of space exploration. The private sector's involvement in space exploration has also grown significantly, driven by visionary entrepreneurs and innovative companies. SpaceX, founded by Elon Musk, has revolutionized space travel with its development of reusable rockets, significantly reducing the cost of access to space. The company's Starship program aims to enable human missions to Mars, embodying the bold spirit of the space race. Similarly, Blue Origin, founded by Jeff Bezos, and Virgin Galactic, founded by Richard Branson, are pushing the boundaries of space tourism and commercial spaceflight, making space more accessible to a broader audience. The technological innovations emerging from these private ventures are not only advancing space exploration but also creating new economic opportunities. The concept of a space economy, encompassing industries such as satellite communications, space tourism, and asteroid mining, is becoming increasingly viable. As more companies enter the space industry, the potential for economic growth and technological advancement continues to expand, promising new possibilities for the future. The scientific community continues to benefit from the legacy of the space race, as space-based observatories and missions provide invaluable data about our universe. Telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope offer unprecedented views of distant galaxies, star formation, and the fundamental nature of the cosmos. Missions to Mars, such as NASA's Perseverance rover and ESA's ExoMars program, are uncovering the planet's geological history and assessing its potential for past or present life. The pursuit of knowledge and the spirit of exploration that characterize the space race endure in contemporary space missions. The search for exoplanets, planets orbiting other stars, has revealed thousands of potential new worlds, some of which may harbor conditions suitable for life. The quest to understand dark matter and dark energy, which make up most of the universe's mass and energy, continues to drive cutting-edge research and international collaboration. In reflecting on the space race, it is clear that this period was more than just a competition between superpowers. It was a catalyst for progress, innovation, and global cooperation. The achievements of the space race demonstrated what humanity is capable of when driven by curiosity, ambition, and a desire to explore the unknown. The legacy of this era continues to inspire and shape the future of space exploration, reminding us that the sky is not the limit, it is just the beginning. As we stand on the cusp of new frontiers, the lessons of the space race serve as a guide. The challenges we face in space exploration today, from the technical complexities of interplanetary travel to the need for sustainable practices, are daunting, but the spirit of innovation and cooperation that emerged from the space race provides a strong foundation. By building on this legacy, we can continue to push the boundaries of what is possible, exploring the cosmos and discovering new worlds. In conclusion, the space race was a defining period in human history that transformed our understanding of the universe and our capabilities to explore it. The achievements of this era, from the first artificial satellite to the moon landing, continue to inspire and drive progress in space exploration. As we look to the stars, we are reminded of the enduring quest for knowledge and the boundless potential of human ingenuity. The legacy of the space race lives on, guiding us as we reach for new heights and explore the vastness of space. Key figures of the space race era. The space race era was marked by remarkable individuals whose contributions were pivotal to the successes of space exploration. These key figures, from astronauts to engineers, played crucial roles in advancing human knowledge and capability in space. Yuri Gagarin. Yuri Gagarin was a Soviet cosmonaut and the first human to journey into outer space. On April 12, 1961, he orbited the Earth aboard Vostok 1, becoming an international hero and a symbol of Soviet space prowess. Gagarin's mission demonstrated the feasibility of human spaceflight and paved the way for future manned missions. Neil Armstrong. Neil Armstrong, an American astronaut, is best known for being the first person to walk on the moon. On July 20, 1969, during the Apollo 11 mission, Armstrong's famous words, "That's one small step for man, one giant leap for mankind," marked a historic achievement in space exploration and a significant victory for the United States in the space race. John F. Kennedy. John F. Kennedy, the 35th President of the United States, played a critical role in the space race by setting the ambitious goal of landing a man on the moon and returning him safely to Earth before the end of the 1960s. His inspirational speeches and strong support for NASA's Apollo program galvanized the nation and provided the impetus for the moon landing. Sergei Korolev. Sergei Korolev was the chief designer and driving force behind the Soviet space program. Often referred to as the chief designer, Korolev's leadership and vision were instrumental in achieving early Soviet space milestones, including the launch of Sputnik 1 and Yuri Gagarin's historic flight. His contributions laid the foundation for Soviet successes in space exploration. Wernher von Braun. Wernher von Braun was a German-American aerospace engineer who played a key role in the development of rocket technology. As the chief architect of the Saturn V rocket, von Braun's work was essential to the success of the Apollo missions. His expertise and leadership at NASA helped make the moon landing possible. Valentina Tereshkova. Valentina Tereshkova, a Soviet cosmonaut, became the first woman to fly in space on June 16, 1963, aboard Vostok 6. Her mission was a significant milestone in space exploration and demonstrated the capabilities and potential of female astronauts in spaceflight. Buzz Aldrin. Buzz Aldrin, an American astronaut, was the lunar module pilot on Apollo 11 and the second person to walk on the moon. Alongside Neil Armstrong, Aldrin's contributions to the success of the Apollo 11 mission were crucial. His work in promoting space exploration continued long after his historic moonwalk. James Webb. James Webb served as the administrator of NASA during the critical years of the Apollo program. His leadership and management skills were instrumental in securing funding, navigating political challenges, and ensuring the successful execution of NASA's missions, including the moon landing. Katherine Johnson. Katherine Johnson was an African-American mathematician whose calculations were vital to the success of numerous NASA missions. Her work on orbital mechanics helped ensure the safety and success of missions, including John Glenn's orbital flight and the Apollo moon landings. Johnson's contributions were later highlighted in the film Hidden Figures. Alan Shepard. Alan Shepard was the first American astronaut to travel into space. His suborbital flight aboard Freedom 7 on May 5, 1961, marked a significant milestone for the United States and set the stage for future manned space missions. Shepard later walked on the moon as part of the Apollo 14 mission. Current space race, journey to new frontiers. The rise of the private sector and new goals. The space race of the mid-20th century was primarily a geopolitical competition between the United States and the Soviet Union. However, Today's space race is markedly different, characterized by the involvement of private companies, the emergence of new national space programs, and a focus on commercial and scientific endeavors rather than political dominance. One of the most significant developments in modern space exploration is the rise of private space companies. Visionary entrepreneurs like Elon Musk, Jeff Bezos, and Richard Branson have founded companies that are revolutionizing the space industry. SpaceX, Blue Origin, and Virgin Galactic are leading the charge, each with unique missions and goals. SpaceX, founded by Elon Musk in 2002, has made significant strides in reducing the cost of space travel through the development of reusable rockets. The Falcon 9, Falcon Heavy, and the ambitious Starship rockets are designed to be reused multiple times, dramatically lowering the cost per launch. SpaceX's ultimate goal is to enable human colonization of Mars, with plans to send crewed missions to the Red Planet within the next decade. The successful launch and recovery of Falcon rockets have proven the viability of reusable spaceflight, and SpaceX continues to push the boundaries of what is possible in space exploration. Jeff Bezos' Blue Origin, founded in 2000, is also focused on making space travel more accessible. Blue Origin's New Shepard rocket is designed for suborbital space tourism, offering a few minutes of weightlessness and stunning views of Earth to paying customers. The company's long-term vision, however, extends far beyond space tourism. Blue Origin is developing the New Glenn rocket for orbital missions and envisions a future where millions of people live and work in space, supported by sustainable infrastructure on the moon and beyond. Virgin Galactic, founded by Richard Branson, is another key player in the commercial space industry. The company's Spaceship Two vehicle is designed to carry passengers on suborbital flights, providing a taste of space travel to those who can afford the experience. Virgin Galactic's focus on space tourism highlights the growing interest in making space accessible to the general public, and the company's successful test flights indicate that commercial space travel is on the horizon. While private companies are making headlines, national space programs continue to play a crucial role in advancing space exploration. NASA's Artemis program aims to return humans to the moon by 2024, with the goal of establishing a sustainable presence on the lunar surface. This ambitious initiative will involve international partners and commercial companies, reflecting the collaborative spirit of modern space exploration. The lessons learned from Artemis missions will pave the way for future crewed missions to Mars and beyond. China has also emerged as a major player in the new space race. The China National Space Administration, CNSA, has achieved significant milestones, including the successful landing of the Chang'e 4 rover on the far side of the moon and the deployment of the Tianhe-Core module for the Tiangong space station. China's space program is rapidly advancing, with plans for crewed lunar missions, Mars exploration, and the development of a permanent space station. The country's achievements demonstrate its growing capabilities and ambitions in space exploration. The European Space Agency, ESA, continues to be a leader in scientific research and international collaboration. ESA's ExoMars program, in partnership with Roscosmos, aims to search for signs of life on Mars. The agency's involvement in the James Webb Space Telescope, scheduled for launch in 2021, highlights its commitment to advancing our understanding of the universe. ESA's partnerships with NASA and other space agencies reflect the importance of international cooperation in achieving ambitious scientific goals. New technologies and international collaboration. In addition to the rise of private companies and the resurgence of national space programs, the modern space race is characterized by the development of new technologies and the increasing importance of international collaboration. These factors are driving the next wave of space exploration, pushing the boundaries of what is possible and opening up new opportunities for discovery and innovation. One of the most exciting developments in modern space exploration is the advancement of propulsion technologies. Traditional chemical rockets, while effective, have limitations in terms of efficiency and speed. To overcome these challenges, researchers are exploring alternative propulsion methods such as ion thrusters, nuclear thermal propulsion, and even solar sails. These technologies have the potential to significantly reduce travel time to distant destinations, such as Mars, and enable more efficient exploration of the outer planets and beyond. The development of small satellites, or CubeSats, is another area of innovation that is transforming space exploration. CubeSats are compact, lightweight, and relatively inexpensive to build and launch. They can be used for a wide range of applications, from scientific research to Earth observation and telecommunications. The growing popularity of CubeSats has democratized access to space, allowing universities, small companies, and even high schools to participate in space missions. This trend is fostering a new generation of space enthusiasts and innovators. The proliferation of commercial satellite constellations is also shaping the future of space exploration. Companies like SpaceX, with its Starlink project, and OneWeb are deploying large constellations of small satellites to provide global internet coverage. These initiatives have the potential to bridge the digital divide, bringing internet access to remote and underserved regions. However, they also raise concerns about space traffic management and the increasing risk of space debris. Addressing these challenges will require international cooperation and the development of new regulatory frameworks. International collaboration is more important than ever in the modern space race. The complexity and cost of space exploration demand cooperation between nations, space agencies, and private companies. The International Space Station, ISS, remains a shining example of what can be achieved through collaboration. Astronauts from around the world live and work together on the ISS, conducting scientific research and demonstrating the benefits of international partnerships. Looking ahead, the planned Lunar Gateway, a space station in lunar orbit, will serve as a hub for missions to the Moon and beyond. This project, led by NASA, involves contributions from ESA, Roscosmos, JAXA, and CSA. The Gateway will provide a platform for scientific research, technology development, and international collaboration, supporting sustainable lunar exploration and paving the way for future missions to Mars. Mars exploration is another area where international collaboration is key. NASA's Perseverance rover, which landed on Mars in February 2021, is part of a broader effort to search for signs of past life and collect samples for eventual return to Earth. This mission involves contributions from ESA, which is developing the Earth Return Orbiter, and other international partners. The Mars Sample Return Campaign is one of the most ambitious undertakings in the history of space exploration, requiring coordinated efforts across multiple missions and agencies. The search for extraterrestrial life is also driving international collaboration. The upcoming James Webb Space Telescope, a joint project of NASA, ESA, and CSA, will provide unprecedented insights into the formation of stars and galaxies, the atmospheres of exoplanets, and the conditions that might support life. This next-generation telescope represents the cutting edge of space science and demonstrates the importance of pooling resources and expertise to achieve groundbreaking discoveries. In summary, the modern space race is a dynamic and multifaceted endeavor characterized by the rise of private companies, the resurgence of national space programs, the development of new technologies, and the importance of international collaboration. As we continue to explore the cosmos, the lessons of the past and the innovations of the present will guide us toward a future where space exploration is more accessible, sustainable, and impactful than ever before. The spirit of the space race lives on, driving humanity to reach for the stars and beyond.